Ladies and gents, I am Bins, and you are watching a new episode in the Shapez BEASTMAM series. Welcome. We've arrived at the second part of our journey, the second part of our story. We spent a ton of time on the topic of the decoder. We gathered all the info we needed to gather in order to be able to understand how the decoder analyzes a target shape. Now that we know, and we also know which cables the decoder throws that we can plug into the physical factory, it's time to have a look at those. If you've been following along, you will know that I've been placing emphasis on a neat structurization of all of these videos, and that structure might become even more important as we move ahead. So we are in chapter 5 now, and chapter 5 will be all about how we're gonna produce the shape. So chapter 5 is called production. Now, let's look at the machine, the physical machine, that is, right? Here it is. Its procedure, its workflow or working method, or whatever you want to call it, we can roughly break it down into two chunks. Production will happen in two stages, let's call it. In the first stage, we will create all of the individual pieces that we will need. More precisely, the floating pieces on one hand and the remainder pieces on the other. They will be produced individually from each other. And then in the second stage, we will bring those pieces together and process them in order to obtain the final result, the target shape. So stage 1 is essentially creating the building blocks, and stage 2 is about putting them together. And I will reflect this in my chapter breakdown as well. First, I want to have a look at stage 1 of production, where the individual pieces are assembled. And if we look at those pieces, we can again distinguish two types. Flat pieces, or in other words, remainder pieces on one hand, and then the floating pieces on the other. And it's the former, the flat pieces, that I would like to look at first. So within chapter 5, we will open up our first sub-chapter, therefore chapter 5a, and that is called Flat and Float. Catchy, isn't it? Within the sub-chapter, Flat and Float, we will open up the first episode, and that is about the creation of flat remainder pieces. So we will call the episode Flat for short. But the episode in turn will also consist of multiple videos, so we hop down to an even deeper level in our chapter structure, and that's how we end up at the topic I want to talk about today: smelting flat pieces. Therefore, chapter 5a, production, flat and float, episode 1a, flat, smelting. The reason I emphasize this structure so much is because terms and topics will repeat across videos and video titles, and I don't want you to get confused. The topic of smelting, for example, has already made its appearance when we talked about the decoder, and it will reappear in future videos as well. So while multiple videos in this series might be about smelting, the context will be different each time. Today, we will specifically talk about smelting within the context of the assembly of flat remainder pieces in the first stage of the production lines. All right? So having said that, if you've seen episode 4 of my Road to SI TMAM series, then perhaps today's video won't contain a lot of new information for you. However, I do want this series to be comprehensive, so I do feel like we need to address the topic. More specifically, the topic of smelting when it comes to automated factories and the challenges that come with it. Now, when you play through Shapez Industries, then the introduction of the smelter creates a ripple through your gameplay. The smelter changes how you thought you needed to play, and it will take some time to adjust to the new mechanics and face the challenges that the game throws your way. if you have plowed your way through the 26 main levels though, and even if you move into free play afterwards, you might notice something. You might notice that the way in which smelting happens in the target shapes you get presented with, they actually constitute a rather small portion of the total amount of possibilities. And now, since we are building a TMAM, a factory that ought to be able to cope with absolutely anything, we need to come up with something bigger, right? Now, as you can see on screen, there are 12 scenarios, 12 ways in which flat pieces can be smelted. And these come in 5 groups. Either the shape isn't smelted, or it is completely smelted, or it's half and half, or it's completely smelted except for one corner, or finally, group number 5, we have 2 smelted quadrants, but the other 2 aren't, creating this kind of T pattern, right? A pattern in shape of the letter T. Now, before you go, oh Bins, what about shapes with fewer than 4 quadrants? Well, let me tell you that that's actually something we don't need to account for if we play our cards right. Now, in the Road to SI TMAM series, I came up with a system that will analyze pairs of quadrants and then determine whether that pair would have to be smelted or not. In the grand scheme of things, it was rather straightforward, but also pretty slow overall. For the BEASTMAM, I wanted to do better, and I came up with something quite ingenious, I think. Let's look at these 12 scenarios, okay? After staring at them for a long time, I figured the following. I decided to firstly group these scenarios into 2 categories. The ones that require smelting on one hand, and the ones that don't on the other, okay? And there is actually only one of these 12 scenarios that doesn't require smelting. That's the first one. The remaining 11 will need a smelter at some point. And from there, I figured, what if I approach this not in a constructive manner, where we bring quadrants together and then we smelt them, but in a destructive manner? In other words, what if we depart from an entirely smelted shape and then apply cuts to it as needed? Have a look at this. For the shapes in the top right category, sorry, wrong mouse button. For the shapes in the top right category, we will need a smelter, right? And a regular cutter, okay? For the shapes in the bottom right category, this one, we will need a smelter and a laser cutter. Hold on, where's my laser cutter? There it is. So a smelter and a laser cutter to cut out one corner. And for the shapes in the bottom right category, could we smelt, then cut regularly, and then laser cut half of it? Because that would mean that we could get by with just 3 operations in total: smelting, a regular cut, and a laser cut. And if we built one module that provides the means to make all 3 of them optional, in other words, a module that has bypass lanes for all of these 3 operations, then that module could cope with all of these 12 scenarios, couldn't it? But wait, there's actually more. If you look closely at each category separately, then you will see that the various shapes we find in them are actually just rotations of one another. So how about we decide that if we need a normal cutter, then we will always cut vertically. And if we need a laser cutter, we'll always cut out the top right part. Because we could then set up a quite linear production line and rotate the pieces as needed, couldn't we? And if so, we could effectively narrow these 12 scenarios down to just 5. Either, number 1, we have no operation. Number 2, we have smelting only. Number 3, we have smelting and normal cutting. Number 4, we have smelting and laser cutting. And finally, number 5, we have smelting, normal cutting, and laser cutting. All right, let's have a look. So this is a rudimentary module of how we could set this up, right? This is not an actual thing, but it gives you an idea about how we could set it up. So for example, we feed a circle into the input. And if we don't need to smelt anything, well, then we're just gonna output it like this. Let's do that like this for a second. We're gonna do that like this, and if we do that, then you see we're gonna have the 4 quadrants of our shape. They would then move into a painting unit, but we're gonna disregard that for this example, right? So if we don't need to smelt, then this is what we would get. That is the first category. Now, let's look at the second category, where everything is smelting. We just send these shapes through a smelter, and we get, instead of 4 outputs, we get just 1 output, right? The entirely smelted shape. That covers the second scenario. The third scenario, we are going to need a smelter and a simple cutter. So if we enable the simple cutter, then you will see we will get 2 halves of the output, left and right. So that's scenario 3. Scenario 4 are these ones. They're the ones where we get a cutout, so we get 3 smelted pieces and then a 4th one that's separate. Well, if I disable this one and I enable that one, that is exactly what we will get. The cutout and the remainder smelted. And then finally, number 5, scenario 5 with the let's call it the T-junction kind of piece, right? For that, we are going to enable all 3 of our modules. So first, we cut the shape in half, and then one of 2 is still going to be laser cut, and that's how we obtain 1, 2, 3 pieces that we could then paint separately and then glue them back together. All right? The next step is going to be rotation, right? Because now we've only accounted for the things that we see on screen, but we still need to be able to rotate this. So let's connect these wires again. And we are going to connect a rotation module for that. And we actually only need 2 of them. One is going to be 90 degrees clockwise. So if we enable that, we're going to get this, right? The second possibility is that we get a 180 degree rotation. That would look like this. And then finally, we could get 90 degrees counterclockwise, which equals, 270 degrees clockwise. And then that would look like this. And that's how we can get any kind of smelt that we might require on any given flat piece. But hold on, because there is an extra obstacle. Right now, we are easily blinded by the fact that our target shape has only circle quadrants. Let's say we wanted to do this shape instead, right? Clockwise, from the top right, this shape consists of a diamond, a windmill, a reverse windmill, and a circle. So let's put that piece in, shall we? Let's put that piece in, like, wait a minute, hold on. Like so. We see in this shape that we want a horizontal cut, right? So basically what we will need to do is provide a vertical cut, disable the laser cutter, and then rotate the shape 90 degrees, right? You're still with me? So we let these pieces move along, and then we rotate them 90 degrees. And now the question is, have we obtained what we need? Well, no, because our target shape is this one. And you can see that even though our smelt-cut combination is correct, because after all, we have a smelted top and a smelted bottom, the quadrants have been shifted, right? So how can we solve that? Well, we actually had a similar situation when we talked about the virtual floating pieces in combination with the nipper. Where is it? Here. Do you remember when we talked about that? The nipper, as a unit, is always going to cut out the top right quadrant of the shape. That's how it works. And if the quadrant that we want to cut out is not the top right one, then we simply rotate the input so that the corner we want to cut becomes the top right. Okay, it's as simple as that. So in this case, it's going to be a 180-degree rotation and then another 180-degree rotation to rotate it back to its initial position. Now, if we move back upwards, as a matter of fact, the very same principle applies here, but it applies on a bigger scale, so it's harder to catch. It's harder to see that that's exactly the same thing we've got going on. This rotation thing that we are doing right here, the rotation that we do after smelting and cutting, that's actually the second part of our rotation. It's the part where we are rotating the shape back to its original orientation. And the only difference is that here we are currently missing the first part of that rotation. Are you with me? So if we have, like in this case, a 90 degrees clockwise rotation at the end, and that rotation equals rotating the shape back to what it was, then it means we actually require a 90 degrees counterclockwise rotation of the shape that we apply before the shape is sent into the smelter and cutter array, right? So let's do that. So we're going to take this shape, and now we're going to send it through like that, and we are going to rotate it 270 degrees, or in other words, 90 degrees clockwise. Now we're gonna let's empty these belts for a bit to speed it up. Now we're gonna rotate the shape 270 degrees before it goes in, and now it gets smelted, it gets cut, it gets rotated, and now we do have the two pieces we need. You can see the circle and the diamond quadrant smelted on the top half, like here, and then we have the windmill and the reverse windmill smelted on the bottom half, like it's supposed to be. Now, how all of this plays out on the wiring layer, which preparations we need to make in order to make sure that the machine does all of this spontaneously and in automated fashion, that part is pretty bonkers, I'm not gonna lie. It took quite a lot to get that done. And we are going to look at that in future uploads. Because, as I've heard myself say at some point, we're not gonna leave any stones unturned. At least that is the purpose. But either way, I already wanted to walk you through this general approach to smelting flat pieces because it totally differs from the approach I took in the regular Shapes Industries MAM I made. And this new approach is a lot more complicated, but in return, we do get those desired pieces out of it a lot quicker. Now, I am noticing that these shapes, they're not being produced the way they're supposed to. So let's try to do a quick troubleshooting. What's going on here? Somehow messing up. Have to be quickly ready. I'm not sure again. Well, I've been playing with this machine a bit between videos, I'm not gonna lie. And apparently I must have done something wrong. The machine is not working the way it's supposed to. Some of it is not coming through. Whatever. Anyway, I'm gonna look at that next time. So, back to our smelting thing. I hope you are excited. I know I am for future uploads, but I'm going to sign out for today. So thanking you very much for watching and wishing you a great day. For today, I am out. Hope to see you soon. Take care, everyone. Bye-bye.